Hello. Now in this question we are having this disk. This is our disk. And its radius is given r. This disk is rolling onto the surface, rough surface. It can be plane also. And its center of mass is moving with velocity v, and the angular velocity of this disk is omega. So we have to calculate the angular momentum of this disk about point P, which is the bottommost point. We have to calculate that. So you see, if you see this disk is not hinged at all. So if this disk is not hinged and this point P is outside of the disk. So if this disk is not hinged, we have a formula to calculate the angular momentum. And that formula is R cross P Cm plus ICM omega. That's the formula. Meaning first we calculate this moment of linear momentum. We calculate the moment of linear momentum about the axis, assuming that rigid body is a point mass. So first we convert this rigid body into a point mass and we place this point mass onto the center of mass and we calculate the angular momentum about the given axis. Then we assume this rigid body is being hinged at the axis itself, and then we calculate. So whenever the body is not hinged, what we do, we put a hinge, then we make a point mass. We calculate these two separately, and that will give us the angular momentum for the complete body about the given axis. So now let's calculate this. R cross PCM, if you see, this PCM is in this direction and that is equals to m into v. And if you see, the perpendicular distance is given r. So that value will be equals to mv momentum multiplied with r. And the direction will be about the axis, if you see, that is the clockwise direction. Plus ICM, we know how to calculate the ICM, that is mr square by 2. That's ICM for the disk multiplied with omega, and if you see the omega, it's given clockwise. So multiplied with omega, and that too in clockwise direction. So both the values are in clockwise direction, so we can directly add them. So it will be mvr plus mr square omega, mr square by 2. And in place of omega, if you see, I can write v by r also. And that will make us 3 by 2 mvr. Clockwise direction, that is the angular momentum of the disk about the bottommost point. Okay. So that's how we calculate. So whenever we are given a rigid body, but that rigid body is not hinged, that system we convert into two systems, separate system. What we do, we place an actual hinge at the axis for the rigid body. And then we convert the rigid body into a point mass. So this is my rigid body. This is also my rigid body, but placed at the center of mass. So there was this rigid body for which the center of mass is moving with velocity v, and the angular velocity was omega. What we did, we divided it into two portions. One for the translatory, second for the pure rotatory motion. So we divide this complex motion, which was the translatory plus rotatory, into two separate translatory and rotatory motion. And corresponding to these, we calculated r cross VCM. And here we calculated ICM omega. That becomes a method. Okay. Thank you.